All right, now let's take a look at example 2, representing proportional relationships with graphs. You can represent a proportional relationship with a graph. The graph would be a line that passes through the origin 0, 0. The graph shows the relationship between distance measured in miles to distance measured in leagues. Example 2. The graph shows the relationship between the weight of an object on the moon and its weight on Earth. Moon, Earth. Write an equation for this relationship. Step 1. Use the points on the graph to make a table. So you locate the points on the graph, and then you put the points on the table. Notice this is the x-axis, and this is your x-axis here. This is the y-axis, and this is the y-axis here. Notice the x-axis is on top, and the y-axis is on the bottom. This is almost always true. Step 2. Find the constant of proportionality. The moon weight, that's your y value, divided by the x value. The moon weight, which is the y value, is divided by the x value. Just like in example 1, y over x. So now, after writing all the points down on the table, 6, 1, 12, 2, 18, and 3, 30, and 5. Okay, after doing that, then you determine your constant of proportionality. So we end up with 1 over 6, that's equal to 1 over 6. 2 over 12, when that reduces down, ends up being 1 over 6. 3 over 18, when that reduces down, ends up being 1 over 6. 5 over 30, when that reduces down, ends up being 1 over 6. All right, let's go through to be sure we know how to reduce. 2 goes into 2 once. 2 goes into 12, 6. 3 goes into 3 once. 3 goes into 18, 6. 5 goes into 5 once. 5 goes into 30, 6. And notice our constant is 1 over 6, 1 over 6, 1 over 6, and 1 over 6. So our constant is the same every single time. All right, step 3, write an equation. Let x represent the weight on Earth. We've done that. Let y represent the weight on the moon. We've done that. And we know that our equation is y is equal to k times x. And we determined that k was 1 over 6. So our equation then is y is equal to 1 over 6 times x. Y is equal to 1 over 6 times x. And we are not forgetting that our equation is following y is equal to k times x. X is the same, k we found out was 1 over 6, and y is the same. Okay, now let's take a look at one more example just to be sure that we have it down.
Hey, sorry, let me just slow down. Just went for a little bit of run there. I need a little bit of exercise. Exercise is important, but it also reminds me about thinking about proportionality. And it's a great opportunity to actually think about how we can actually find proportional relationships, even in things involving speed. So, let's think about this fun challenge together about Caleb and running. So, we're going to take a look at a graph that shows the relationship between the number of minutes Caleb runs and the distance he runs. And our challenge is to write an equation for this relationship. So let's just take a look at the graph first and see if we can think about it. So on the x-axis, or on the horizontal axis, we have the time he's run in minutes. And then on the vertical, or the y-axis, we see the distance that he's run in miles. So what we can do, first of all, is just to make meaning of this, we can actually think about looking at certain points that actually appear on this graph. Remember, our goal is to see if we can write an equation for the relationship, but first let's understand the relationship. So what I see here is that there are a bunch of, this line has a bunch of points that we can study. Let's just pick some of them and write them down. So for example, there's a point right here that's easy to see. I hope you can see that. The time is 8 minutes, and in 8 minutes the distance is, and even though it's not marked, you can see this is 2, 4, and so these distances are 2, that's 1. So 8 minutes, he's run 1 mile. So that's pretty good, actually. So time of 8 minutes, he's run 1 mile. Now, let's take a look at this dot right here. That means when the time is 16 minutes, he's run 2 miles. So I'm going to mark 2 down for the corresponding distance that he traveled. Now, notice that at 24 minutes, it seems that he has gone 3 miles. And at 40, that's right under the arrowhead. There's a dot right there. The arrowhead's actually not showing us, but if you walk across or run across, you see it's 5. So we see that 40 minutes, he's traveled 5 miles. So with these ordered pairs, we can now take a look at the corresponding ratios and see if the ratios are constant. If they are, then we know we have a proportional relationship. So let's just see if we can figure that out. And the ratios that I'm going to look at are given by the distance divided by the time. And so let's see what this equals. And this, by the way, is a way of actually figuring out speed or velocity, distance over time. Okay, so let's take a look at the first one, distance. That's 1 mile traveled in 8 minutes. And so we get a ratio of 1 over 8. And that actually, I'll just write here as 1 over 8. Now, in the next ordered pair we have, we see the distance is 2 miles in 16 minutes. So we see the ratio of 2 to 16. And if we simplify 2 over 16, we see 1/8. I'm sensing a pattern. What about this next ordered pair? Well, the corresponding distance is 3, and the time was 24 minutes. So I'm seeing a ratio of 3 to 24, and the fraction 3 over 24, that can be simplified to, let me hear you say it, 1/8. And then the last ordered pair we have has a distance of 5 with a corresponding time of 40, and so we see 5 to 40. And 5 to 40, or 5 over 40, can be simplified to, I heard you, 1/8. Well, you can't help but notice that in each one of these, the ratios produce 1/8. So we see a constant ratio, which means that this relationship is a proportional relationship. Awesome, because we know exactly how to write the equation for proportional relationships. It always has the flavor y equals k times x, where x is the independent unknown, so that in this case would be time. The y is the output, which in this case would be distance, and the k is a constant number. That's just a number, and it's actually the constant of proportionality, which in this case is just that constant ratio we found. So that k is always going to equal the constant ratio that we found. So the equation for this particular relationship would be y equals 1/8 x. And that produces an equation that actually captures not only this relationship, but actually captures this graph. So this graph has an equation that looks like y equals 1/8 x. And so you can see that y equals 1/8 x actually is the equation, in this case, of a straight line, which is kind of interesting. And so, in fact, remember that we've already seen that we can just look at a graph and determine if it is, in fact, representing a proportional relationship because there's two things that are involved. We have to, when we connect the points, have a straight line, and the straight line has to pass through the origin. So just looking at this graph, we know that in fact it's representing a proportional relationship because it's a straight line that passes through the origin. Now, by producing some ordered pairs, we can actually determine what that constant of proportionality is, and then we can actually write the equation of it. So now we're actually writing equations for straight lines. Why? Because these particular straight lines that pass through the origin are in fact proportional relationships. Proportionality is all around us, even when we run. So next time you're going and exercising, realize there's math all around you, and in fact, as you're moving, you are mathing. Anyway, I'll see you soon. Back to my run.